hello.
It's
time.
4.9. And
we're
feeling
fine.
Nice. We're going to be multiplying polynomials, and we will not be foiled by this. You see, I say that because we use FOIL to expand and simplify binomial products, where we said we would take the first terms and multiply them, and we'd multiply the outside terms and the inside terms and the last terms. But the thing that we really did there is ensured that by multiplying the first term in the first binomial by everything, and multiplying the second term by everything in the second binomial, we've ensured, straight up, that every term in the first poly gets multiplied by everything in the second poly. And that's the principle we're going to apply as we move forward to multiplying higher order polynomials. We're going to ensure that every term in the first polynomial gets multiplied by every term in the second polynomial. Whoop. Whoop. And a fun little fact about us doing that is that the number of terms in the initial expansion, when we do that initial multiplication, will be the product of the number of terms in the polynomials. With binomials, it was 1, 2 terms being multiplied by 1, 2 terms. And before we simplified things, just when we did the initial expansion, we got 2 times 2 equals 4 terms. If we have a trinomial, which has 3, and a binomial, which has 2, that initial product should give us 6 terms before like terms are collected.
Alrighty. So we're going to look at this first example here, and I'm going to find a different color to do so with. I'm going to go yellow for the highlighter, and I'm going to go blue, because I'm a nice, proud Ukrainian. Anywho, so right here we have a binomial. We know that because it has 2 terms, multiplied by a trinomial because it has 3 terms. We know that 2 times 3 is equal to 6, so we should expect 6 terms before we collect any of them, before we simplify. So that's a nice check to make sure we've done all of the multiplication bits. So for starters here, we might realize that we're back to expression land. We have no more equations here. There's no equal signs already taking part. So on our next line, we need to make sure we start off with an equal sign so that we don't get that E9 error. All right. As Mr. Eighth said, we need to take our first term and make sure it's distributed to every single term in our second polynomial. So we're going to start off by multiplying 2x and x squared, which gives us 2x cubed. Next, we're going to take that same 2x. Now we're distributing it to the middle term. So we're going to get negative 12x squared. And again, we're going to take that 2x and we're going to go ahead and multiply it by our last term, which will give us plus 6x. I'm going to move this down a little bit just so I have room for my distribution lines. Now, maybe I'll just straight up erase them. That might work. I also did the same with that second term in my first polynomial. I have to distribute it to every single term in that last bracket. So 1 times x squared is just x squared. 1 times negative 6x is negative 6x. And 1 times 3 is positive 3. Now, one thing I will note is you can go ahead and write everything in one giant line. That is more than acceptable. What some people find is more of a preference to them, and they could use as a strategy, is I can go ahead and line this up with another term from my expansion that has the same power of my variable. So my 12x squared and my x squared have the same variable. They both have x squared. So I'm going to line them up. Same with my positive 6x and my negative 6x. And my 3, well, doesn't line up with anything, so that's all right. You may use that as a strategy, but it's not completely necessary. One thing we also might notice is that before I simplify anything, I end up with 6 terms, just as I anticipate.
Oh, sick.
No, it's 6.
Oh.
Yes. Now, I'm going to collect all my like terms. So I have 2x cubed, and now I'm going to collect all my x squared. So I have negative 12x and negative 12x squared and positive x squared, so that means I get 11x squared. And then 6x and minus 6x, well, those cancel out, so I'm not going to include them at all. And then my constant is just plus 3, so this is what I end up as my final simplified expansion.
That was a binomial being multiplied by a trinomial. We can go even bigger. So a trinomial getting multiplied by a trinomial is our next example.
How many terms would you think we would expect?
If I had to guess, I would say that we're going to have 3 times 3 to give us around 9 terms,
Well,
plus or minus 0.
Only time will tell.
Yeah, and then we will tell as well.
Yeah.
So first off, I'm going to take x squared, and I'm going to multiply it by everything. So x squared times 2x squared is 2x to the 4. X squared times negative x gives me negative x cubed. X squared times negative 1 is negative x squared. That's that first set of multiplications done. You know what? I should probably dare you to try the rest, so I dare you to try the rest before we move on.
Ooh, you gotta do it. He's dared ya.
Pause this video, see if you can do it, and then I'll just keep plowing ahead right now. I'm going to use the Thibodeau patented staircase method here that I see. And when I do these multiplications, I'll line them up. Negative 2x times 2x squared is negative 4x cubed. Negative 2x times negative x is positive 2x squared. Negative 2x times negative 1 is positive 2x. Really bouncing all over. And then finally, the 5 times everything. So 5 times 2x squared is 10x squared. 5 times negative x is negative 5x. 5, close enough. 5 times negative 1 is negative 5. And we can add everything up now. So
Wait, let's see. Do we have 9 terms before we simplify?
Oh, I do, because I have, in a different color, I've got 3 terms here. I've got 3 terms here. I've got 3 terms here. I've got 3 groups of 3, if you will. So that'll give us our 9. We good. Back to the OG color here. Simplifying things, nothing in common with 2x to the 4. We've got negative x cubed minus 4x cubed. We've got negative x squared plus 2x squared plus 10x squared. That 11 looks a little rough. 11x squared. 2x minus 5x. And then a straight up negative 5. So we can use this as a very straightforward kind of algebraic method of multiplying polynomials.
All right, so that's one way to go ahead and multiply those polynomials. Some people prefer doing it in a straight line, like we said you could do it at the beginning. Some people prefer that staircase method. There's also a rectangular method or a rectangle method, and it's just another way to ensure all terms are being properly distributed. So what we would do is we would create this sort of rectangle. What goes on the top and what goes on the side of the rectangles? Well, those are our polynomials. So for example, here we have 2x plus 1 multiplying with x squared minus 6x plus 3. So we would take each of those polynomials, put one of them on the side, and then the other one on the top. And it doesn't really matter which one's which. Okay. Notice that if there is a sign that is before that term, so this had a plus 1, I'm going to include a positive 1 here. If I have a negative 6, I'm going to include the negative 6. Right? The signs do matter, but in this case, if we're using a plus, it's implied if we don't write it down. Okay? All right. Once we have that kind of set up, a rectangle set up, what we would do is we would take the first term here and the first term here and multiply them to get us that spot in the rectangle. And we would go ahead and continue doing so. So we would kind of see where they line up in the rows and the columns, and that is what we would multiply to get that value. At the very end, we would then go ahead and collect those like terms and we would simplify. What you might notice is that all my terms with the same powers of x will be found on my diagonals here. So that's something kind of cool. It's not lined up and down like it was in the staircase method, but it's still quite easy to find and a good way to check to make sure you're not goofing up on any of those multiplications.
In fact, the reason why it doesn't line up like in the staircase method is if you take this thing, bloop, and chuck it over here, we've really just offset everything by one little bit. Right? We've taken this row and shoved it over there. And now we have our rectangle. So they really are giving us the same thing. That's that. Any poops, let's use a rectangle method to expand and then simplify. So I'll have 2 terms and 3 terms. Maybe I'll go 2 terms here with a 3x and a -2. And up here I'll have a 2x squared, I'll have a 4x, and I'll have a -3. And I'll do some multiplication. So 2x squared times 3x is 6x cubed. 4x times 3x is 12x squared. -3 times 3x is -9x. And same, we're going to multiply all these things by -2 to fill in as follows. I don't need to write a positive. There's that. Those are all the terms. Now we are going to simplify however we can. There does need to be a statement somewhere that this is equal to something. I might just write it somewhere. So I'll say that this is equal to, well, 6x cubed doesn't combine with anything, so I'll just write that it's 6x cubed. We've got -4x squared and 12x squared, so combining those like terms, we've got just positive 8x squared. We've got -8x and -9x. And then finally, there's just this lone 6 dangling about there. This thing is done.
All right, last but not least, we have 2 polynomials here. We have this one with 3 terms, this one with 4 terms. We can expect to end up with an unsimplified version of 12 terms. Well, let's just see what's going to happen. I'm going to erase all this because I'm eventually want to prep my answer there. Maybe I'll put this guy on the side. I don't know. Oh, already started on a bad note. That was supposed to be a 2. 2x squared. I have my -x and my -3. Then I have my 4x cubed. I have my -2x squared. I have my 3x. And I have my 4. All right. I've made my rectangle. Now I'm going to go ahead and make sure I get all of these rectangle boxes filled in by multiplying whatever is in my row and that column together. So starting off, I'm going to go 2x squared times everything in this, in each of the columns. So 2x squared times 4x cubed should give me 8x to the power of 5. 2x squared times -2x squared should give me -4x to the power of 4. 2x squared times 3x should give me 6x cubed. And 2x squared times 4 should give me 8x squared. If you haven't already, pause this video, finish this off, but we're going to keep on rolling. So -x, now again, distributing it to every single term in that second polynomial. -x times 4x cubed is -4x to the power of 4. -x times -2x squared is 2x cubed. And continuing on, we should get -3x squared and -4x. Last but not least, distribute that -3. So I get -12x cubed. I get positive 6x squared. I get -9x, and I get -12. Of course, doesn't really help me if I just leave it in that rectangle there. I need to indicate what my final answer is equal to, so I need to have that equal sign. And I can see that my 8x to the power of 5 doesn't combine with anything else. I have my x's to the power of 4 there, so I have negative 8x to the power of 4. I have my x to the powers of 3. Those combine to, what do we got? 8x cubed, so minus 4x cubed. We have my x to the power, so sorry. X to the power of 2's. And we end up getting 11x squared. I'm going to zoom out just a smidgen. Oh, running out of room here. Maybe I'll just make this a little bit smaller. Oh, so cute. And then zoom in. Next here, let's collect all of my x's. And then we get negative 13x. And then we have, where's a nice purple highlighter? Our negative 12. Oh, so nice.
Man, it looks like a unicorn did it. So magical.
But better, we did it as a team. So, there's some practice here that you could check the textbook out.
Nice.
And otherwise, that's all for now.
Peace out. Goodbye, friends.